In the previous chapter, we have understood about structural analysis. We have seen how to perform a static structural analysis. We took various examples of a 3D problem, axisymmetric problems. We took an assembly. Also, we understood some important concepts related to static structural analysis like factor of safety, convergence, what is stress singularity. Okay, so we've understood some important concepts. Now the next chapter that we are going to start with is wizards and tools. Okay. Now let us first understand what is this wizards and tools, and then we will see how to work with it. So in Ansys Workbench, we have a different number of tools and wizards that are available. Now these tools and wizards are actually there to help the user to complete the analysis process. So with the help of these tools, we can complete the process by following the rules and following the steps. Okay. So when you want to use the wizards and tools in the mechanical window, you will have to click on this green colored arrow that appears there. Once you click over there, you will get one mechanical application wizard box just on the right hand side of your graphics screen, and in that you will see that there are some steps that will appear, and you just have to follow these steps to complete the process. Now in this application wizard, let us first go to the wizard. Let me go to the mechanical cell. Okay. Now here, if you see, this is the button that we are talking about. So once you come to the mechanical window, you can click over here. Once you click over here, you will see that the mechanical application wizard will open. Okay, and these are the steps which you need to follow. Now, in the mechanical application wizard, you have different wizards that we can use. We have separate wizards for stress analysis, for fatigue analysis, modal analysis, thermal analysis, magnetostatic, contact regions, for defining contact regions. Okay, so these are the different wizards which we can use for different types of analysis. Okay, so this is nothing but the wizard tools. Now to understand the wizard tool, what we will be doing is we will be taking one example of a fatigue analysis, and we will solve the fatigue analysis using the wizards and tools applications. Okay, but before we start solving the problem, first let us understand what is fatigue analysis. Now fatigue analysis is nothing but it is a progressive and localized structural damage that occurs when a material is subjected to cyclic loading. Okay, that means whenever a design or a model is subjected to cyclic loading. Cyclic loading means the load condition is in a cyclic manner. Means we are continuously loading the structure and unloading the structure. Now this situation will go on happening for a very long time. So whenever such a condition is there, fatigue will occur in that design, and we need to analyze the fatigue line. Okay. Now fatigue occurs when a material is subjected to repeated loadings and unloading. That is nothing but cyclic loading. Okay. Now when this is happening, the model starts to deform. So when you are applying the cyclic loadings on a design, the model starts to deform, and after some cycles of loadings, small cracks start developing in the design. Now these cracks then gradually start increasing, and suddenly the structure will fail. So when you start loading and unloading the design, wherever the design is weak, there cracks will start to develop. Initially they are all small cracks, but as the cyclic loading continues, these cracks will go on increasing, and then a certain point will come when the structure will fail. So in fatigue analysis, we need to understand for how many cycles the model will last, or how many cycles the model will sustain. Okay, so this is what we need to calculate in fatigue analysis. Now when you talk about fatigue analysis, as we discussed, we have to calculate the fatigue life. Now what is fatigue life? Fatigue life, which is denoted by NF, it is defined as the number of stress cycles of a specified character that a specimen sustains before failure of a specified nature occurs. So it is not, in simpler words, it is nothing but it is the life cycle of a model, of a material. Okay. Now to calculate the fatigue life, there are different methods. Now the methods that we will be discussing is, we have two methods, that is uniform material law, which is also called as the UML method, and the second method is SN curve. Let us talk about the UML method first. The UML method was developed by the end of the 20th century, and this method was developed to determine the fatigue life of aluminium and titanium alloys. But later this method was also extended for other high strength steels and cast iron. This method was very easy and user friendly to use because it required only the tensile strength data of materials. So that is why it was very easy and handy method that could be used. But there was a drawback in this method, that it could be only used for high strength steels. Okay. Then the next method that we are going to talk about is SN curve. The SN curve is nothing but when the cycles are more, when the loading cycles are more, the SN curve is generally used to calculate the fatigue life of the material. The SN curve is also called as Euler's curve. It is a plot, or it is a graph of stress versus the number of cycles, that is N, which is known as the SN curve. So it is actually a graph of stresses, the number of cycles. Okay. Now even the SN curve has some limitations. Now what are the limitations that occur in SN curve? That is, the SN curve is affected by conditions like corrosions, temperature, and presence of sharp corners. So because of this, even the SN curve has some limitations. Okay, and you can see over here we have an example of the SN curve for steel, and we have another example for SN curve of aluminium. Okay. Now when you talk about the SN curve, there are different theories on which the calculations of SN curve depend. Okay. Now, theories that we are going to talk about is, you can see this graph over here first, and you can see different curves A, B, C, and D. So the A plot over here is it is a plot of a SN curve which has been done using the Soderberg theory. Then the B plot is according to Goodman theory. C plot is according to Gerber theory, and the D plot is according to mean stress curve. Now in Ansys Workbench, you will see that the alternating stress mean stress graph or the curve is already present in every material. With the help of this graph, we will be able to calculate the fatigue analysis. But if you want to change the theories, we can also change the theories according to which we want to calculate. Okay, so you will observe this when we perform the fatigue analysis. Now we will see another thing that is important that we need to understand in fatigue analysis. As we discussed, fatigue analysis or fatigue occurs when a model is subjected to cyclic loading. Okay. Now when you talk about loadings, there are two types of loading conditions that can be studied in fatigue analysis. The first loading condition is called as a fully reversed loading condition, and the second loading condition is called as zero based loading condition, or it is also called as repeated loading. Now what is the difference between the two? If we consider that the load is a fully reversed load, then let us say my load acting is 100 Newton. So the loading condition, if it is fully reversed, Okay, if it is fully reversed, then the loading condition acts in this manner. It goes from 0 to positive side, again 0 to the negative side. It is like this. You see over here also, a fully reversed loading condition is like this. It will go to the positive side, that is 100, 0, and this is negative 100. So the loading condition will be, it will be exerting a positive force, plus while going back it will also create a negative force on the model. Okay, so this is what happens in a fully reversed loading condition. But in the other condition, which is the zero based loading or repeated loading, in zero based loading condition, the load gets applied in this manner. It only goes in the positive direction 0, it gets applied like this. It never goes to the negative side. Okay, so these are the two types of loading conditions that we need to understand. So let us just see what we've understood. What is fatigue analysis? Why are we performing it, and when we do need to perform the fatigue analysis? We've also understood what is fatigue life. We've seen what are the different methods to calculate the fatigue life. We've understood the two methods, that is UML and SN curve. Then we discussed about the different theories that are used to determine or predict the SN curve. And then we have understood about the different types of loading conditions that are involved in fatigue analysis. Okay. Now we are going to solve the problem for fatigue analysis. Okay. So we are going to take an example of a 4-stroke crankshaft. Now this 4-stroke crankshaft is subjected to loads at these pins. Okay, the load value is 25,639 newtons. So over here and over here it is acting in the negative y, and over here and here it is acting in the positive y, and this will be repeated for number of cycles. So we need to understand for how many cycles this model will last. Okay, the material that we are going to be using for this analysis is aluminum alloy. Okay, and the model, we can create a crankshaft, 4-stroke crankshaft as per the design. Okay, now let us go to Ansys Workbench. Once you come over here, we will add one static structural. Now as we saw over here, we need to use aluminum alloy for this analysis. So I will click on the engineering data, we will click on the data resources, general materials, and I will add the aluminum alloy. Once that is done, check whether it has been added into the outline of schematic. Return to the project and then import your model. So let me import my design. This is my model that I am going to use. Enter into the geometry design modeler and see your design. Set the unit system and generate the model. You can see the design now. So this is the 4-stroke crankshaft that we have. Okay. Now let us go to the mechanical model. Now once you are in the mechanical model, the first thing that we need to do over here is we need to change the material. So we have to use aluminum alloy for this analysis. I have changed the material. Then we will create the mesh. Now as we can see very clearly that we have very small areas, filleted regions. So instead of doing the default meshing, I can come for proximity and curvature, and then I will update the mesh. Now because of the use of proximity and curvature, the meshing will take some time because it will generate fine meshing. So now you can see that the elements have been generated and we've got the meshing. Okay. The number of elements generated are 1,28,254. We can also check the element quality. We have all tetrahedral elements. These are the elements that we have generated. Okay. After that, now we will go to the next step where we will apply the loads. But for this, I am going to take the application wizard. Now see, when you come over here, you can just click on these steps. So the first step is we have to verify the material. We have already done that. After that, we need to add the number of steps. Because we are performing static structural analysis, we are going to take only one step. And whenever you perform static structural analysis, you need to remember that the run time or the analysis time is only 1 second. Then now the next step is we need to insert the loads. So once I click on this step, it also points to me where on which option can I use for inserting the loads. So I take the loads option and now I'm going to select the force. So now I'll select this space and this space plus this space and this space. And now the value of the force that is going to act is, you can see over here, it is 25,639. Now this force value has been calculated by some calculation using the piston dia, pin dia. Okay, there is some theory which is used to calculate the load value. Okay, so it is 25,693 newtons, and then we have to give the direction. So for direction, because I don't have a straight line in the y direction, I will resolve it using the components. And I will say it is 25,693 newtons. You can see the direction is in the upward direction. Okay. Now again I will apply one more load, but this time it is over here and over here. Again I use the components, and this time it will be in the negative direction. So 25,693, so that they act in the downward direction. After this, I need to give the supports. So when I say insert supports, you will see the supports option. And now I'm going to fix all the surfaces. Use your control key, keep your control key pressed and start selection of the faces. So you can drag your mouse over here so that all the faces get selected. So the selection becomes very easy. Okay, you can select this also. You can go to the opposite side and select again. Make sure you don't leave any surfaces. Okay, fine. So we have selected all the faces, and now I will say that they have to be fixed. So my boundary conditions are such that all these faces are fixed, and then we have loads acting on the pins. Okay. Next, now we have to solve, but before we solve, I need to add the results. What do I want to check? So I want to check the equivalent stresses and the total deformation. And now we will say solve. So where do I need to click? So I'll click over here so that we solve the analysis. So now the model will be solved and we will get our results. Because we have used the proximity and curvature option, the meshing is very fine and thus the runtime will be more. Okay, now we will click on equivalent stress to see the results. You will click on total deformation to see the deformation. So as I said, the result has been scaled. If I see the true scale, you will see this is the result. This is my deformation and this is my stresses. So the stress is 208.42 megapascal. Okay. Now I need to perform a fatigue analysis. Okay. So I'm going to use the wizard, fatigue analysis wizard, for performing the fatigue analysis. Okay. So once your supports have been inserted, click on the solution tab, right click and insert a fatigue tool. Okay. Right click on the solution node, insert, add the fatigue tool. Once you add the fatigue tool, then you need to perform these steps. Okay. So the first thing is you need to add the fatigue results. What exactly do you need in the fatigue results? So I need to add the life. I need to I need to calculate the fatigue life, fatigue damage, or factor of safety. The same thing can be done from here. Right click, insert life. Okay. So now I need to calculate the fatigue life. Okay. Now when you click on the fatigue tool, we spoke about or we discussed about the types of loadings in the PPT. Okay. So we have two types of loadings. So here is the type of loading that we spoke about: fully reverse and zero based loading. First, we are going to calculate the fatigue life according to fully reverse. That means the load that we have applied is 25,693 Newton. So the load will be acting in such a manner, from 25,000 it will go to 0, again to the negative side. So it will be in a cyclic manner. Okay, and you can also see the theories. We spoke about the Solidworks theory. These are the different curves. See, these are the different curves that we spoke about: curve A, curve B, curve C, and curve D. Okay. Now, before we do the fatigue analysis, there is one more important thing that we should know. Come to the project schematic window, double click on engineering data. The material that we are using is aluminium alloy. Now, as I said, every material that we have will have one alternating stress mean stress curve. Okay, and in this you can see the number of cycles and the stress value. You can see the SN curve over here. Okay, so now this will show that if the stress value is somewhere around 275 megapascal, then it will last for 17,000 cycles. But if the stress value is lesser than 82.74 megapascal, it will last for 1 e raised to 8 cycle. That means the maximum number of cycles for which this material can last. According to our analysis, the stress value that we have got is 208, okay, which is higher than the minimum stress. That means now we can see the number of cycles. Okay, so we can select live, right click, and we can say solve. And in the live you can see the minimum number of cycles. The minimum number of cycles for which this model can last is 31,069 cycles. Maximum cycles is 1 e raised to 8, which is the same thing that we understood over here, 1 e raised to 8. And the minimum number of cycles is 31,069 cycles. Now this is for the fully reverse cycle. But if I change it to zero based, okay, then what is the change? Now here the life will increase. You can see now it is going to last for 1.5 0.0496 e raised to 7 cycles, because the zero based type of loading is less, it will have lesser effects, okay, as compared to the fully reversed loading condition, okay. And you can also see the theory type, okay. I can change it to the Goodman theory. You can see the Goodman theory, Soderbergh, or according to Gerber. Same thing we can see over here also, okay. So the theories can change over here, and then you can calculate. You can change this to fully reversed, Soderbergh theory, and solve. Okay, so you can see this is the way by which you can perform the fatigue analysis. Okay, let us just discuss this. What we have understood in this chapter, we have understood about fatigue analysis. What is the meaning of fatigue analysis? What is the meaning of fatigue life? What are the different methods by which you can calculate the fatigue life? We spoke about SN curve, and then we've seen what are the different theories on which the SN curve depends. What are the types of loading condition? And then we've taken this example. And always remember that the fully reversed type of loading will always have lesser life cycles as compared to the zero based loading. That means fully reversed loading condition is much severe as compared to the zero based loading condition. Okay, so this is how we will perform the fatigue analysis, and this is how we will use the wizards and tools. Now the last part over here is view report. You can click on view report over here, which will generate a complete report of your analysis. So you can come to the report preview and you can see the entire report of your analysis, which shows all the details of the analysis that we performed. It gives the entire data. Okay, and in the end it will also show the results. The minimum life cycles is 31,069. Okay. Now in this case, this is the report that we've generated. Now this report is in an HTML format which can only be viewed in Ansys Workbench. But you have an option over here which is send to Microsoft Word or Microsoft PowerPoint. So you can export this report from Ansys Workbench to a Word format or to a PowerPoint format. Now let us say if you want to add these images, click on the geometry to come back to the geometry view. Let us say you want to add these images to the reports. So first you need to capture these images. To capture the image, first select the option, and here you will see one option over here. You can say image. So I'll click on the image option so that this image is captured. Similarly, I also want to capture the fatigue life image. So I'll click on this and I will again click on image. Now you'll see that two images have been captured. Again go to view report. Again the report is generated, and now this time the image will also be taken into account while generating the report. Now click on the graphics screen. Now again go back. See, you can see that the images have been added in the report now. Can you see this? This is how you will use your mechanical application wizard to perform the analysis, and the same wizard can be used to generate a report of your analysis. And this report that we generated can also be exported to different formats. Okay. So with this we finish how to perform fatigue analysis.